Here we are asked to find the IUPAC name of each of the three compounds and to draw some structural formulas related to compound D. Compound A is a ketone because it has a carbonyl group. We can first find the longest carbon chain to get the parent name. The longest chain has 4 carbons, so the parent or root name is bute. The suffix indicates carbon-carbon single, double, or triple bonds and any functional group. The backbone is saturated, so we write an, and since the functional group is a carbonyl group, the suffix is -one. Next, we number the chain closest to the end where the functional group is. We have already numbered the chain from the right, closest to the carbonyl. Next, we can give the position of the functional group in the chain in the suffix. Since the carbonyl is on carbon 2, we could write butan-2-one, but a 4-carbon chain ketone can only have its carbonyl on carbon number 2, and so we can just leave out the number 2 here and write butanone. Then we write the substituent names before the parent name in alphabetical order, indicating their position and using prefixes to indicate if there is more than one of the same kind. The only substituent is a methyl group on carbon number 3, so the prefix is 3-methyl. The name of this compound is 3-methylbutanone. For compound B, which is a branched haloalkane, the longest chain is 7 carbon atoms, and so the parent name starts with hept, and since there are no functional groups other than the chlorine atoms, because remember halogens are considered functional groups, the suffix is just -ane. We can number the chain closest to the chlorine atoms to give the lowest numbers for these substituent functional groups. There are 2 chlorine atoms on carbons 2 and 6, so we write 2,6-dichloro. And there are 2 methyl groups, one on carbon number 2 and one on carbon number 5, so we write 2,5-dimethyl. C comes before M in the alphabet, so the chloros are written before the methyls. This compound is 2,6-dichloro-2,5-dimethylheptane. Compound C is an alkene. Its longest chain is 6 carbons, so we write hex. And we use the lower of the 2 numbers of the double bond to indicate its position. The double bond is on carbon number 2, so we write 2-ene. There is a methyl group on carbon 2 and an ethyl group on carbon 3. We must write 3-ethyl before 2-methyl, since E comes before M in the alphabet. This compound is 3-ethyl-2-methyl-hex-2-ene. There is a last rule which we have not needed to use here. If there is more than one double or triple bond, or more than one functional group for that matter, we write di, tri, etc. before it in the suffix. Lastly, we need to write the structural formulas for positional isomers of compound D, which is C4H10. And we said in the previous video that this could be an alcohol, although it could also be an ether. We need to draw 2 straight chain positional isomers. Positional isomers have the same molecular formula, the same functional group, but the functional group is on a different position in the chain. 2 straight chain positional isomers would be butan-1-ol with a hydroxyl group on carbon 1 and butan-2-ol with a hydroxyl group on carbon 2.